Alright, this is the second half of a review that we are doing on a unit of circles and spheres. We're doing area, volume, surface area, all that good stuff. But this is the second video, so if you did not already take a look at the first video, which included numbers 1 through 6, you might want to pause and go back and check that out. But we will pick up here with number 7 through 14. Okay, anytime you want to find the area between two shapes like this, you're going to take the outer shape and subtract the inner shape, like cutting it out. This one should be relatively easy because both shapes are circles. So we're just going to do the big circle minus small circle. Because they are both circles, both areas will be calculated by doing pi r squared. A little pi r squared. Okay. Now for the big circle, we need the radius. Is 5 the radius of the big circle? No, that's the radius of the small circle. Is 4 the radius of the big circle? No. 4 is just this little piece. It's not a radius. The radius has to come from the center and it has to go all the way out like this. That red segment I just drew, that's a radius. Now fine, this part of the radius is 4. What's this part? Yeah, this part down here is 5. Right? You can see it because of this is the radius and it should be the same everywhere in this little circle. So 4 plus 5 is 9. Okay, so if that's 4 and that's 5, that means the entire radius is actually 9. Okay, so that is the radius of the big circle. So when I go to do the area of the big circle, pi r squared becomes pi times 9 squared. Now we need to subtract the smaller area. The radius of the small circle is 5, so that's going to be pi times 5 squared. 9 squared is 81, so that'll be 81 pi. 5 squared is 25, so that'll be 25 pi. These are like terms, so I will keep going and I can put these together. And I know that 81 minus 25 is 56. So this will be 56 pi. Okay, and that is the answer. This is area, so we'll do meters squared, square meters. If you wanted a decimal, you could get one. Okay, 56 pi. Alright, toggle button, 175.93. Okay, is the decimal form of the same thing. That is how you do a shape inside of a shape. Alright, let's look at another one. This time we have a square inside of a circle. So we need to do the outer shape minus the inner shape. So again, the circle part is going to be pi r squared. Now the square, like any rectangle, you can find it by doing the base times the height. Let's do the circle first. You see the radius right here is 12. So this area of the circle is going to be pi times 12 squared. Now we need to subtract the square. This is slightly tricky. And to me the easiest thing to do is to look at this as the hypotenuse of a right triangle that goes like this. Okay, so if you look at this right triangle that I've just emphasized, first of all, the hypotenuse here is 24. Okay, because you see this 12, that's the radius, that's half. So the whole hypotenuse here is 24. This is a 45, 90 triangle. Alright, because we split a square in half. Now we have special properties that we can be aware of. If I can find them quickly for you. Bam! These are the properties of 45, 45, 90 triangle. It goes leg, leg, and then leg radical 2 for the hypotenuse. So focus on that x radical 2, see how it sits at the hypotenuse. Here we have a 24. That 24 should equal x radical 2. So if I were you, I would take that 24 and I would set it equal to x radical 2. X radical 2 must equal the 24. They're both in the same spot. Hypotenuse 24, hypotenuse x radical 2. They have to be the same. The point is I can find x now by dividing. Okay, so if I take this and I divide, alright, divide both sides by radical 2. Those cancel out. Now what am I going to get? Well, 24 divided by radical 2. Let's put that in the calculator. Just let me be clear. 24 over radical 2 is 12 radical 2. Whoops. So we just found x. We found that x is 12 radical 2, yeah? Alright. I'm going to write that up here. Hey guys, x is 12 radical 2. But what is that x? Look back at your diagram. See these x's? That's what we just solved for. These are the sides of the square. Well, you know, the right triangle in this case, but the square in this case. So we just found the sides of the square. That means this right here is 12 radical 2. And this side over here also 12 root 2. Why did we do all this? Because we needed to be able to do the base times the height to find the area of this square. And now we've got it. So the base is 12 radical 2. And the height is also 12 radical 2. Okay? So let's work this out. Can't we just work this all out? I believe we can. No, I want purple. Purple. 12 squared is 144. So this is going to make 144 pi minus. Put this in your calculator. 12 radical 2 times 12 radical 2. Like this. Alright, 12 radical 2 times 12 radical 2. That turns out to be 288. So 288. Look, this has a pi, this doesn't. That means these are not like terms, so they cannot be put together without making a decimal. So if I wanted an exact answer, that would be it right there. Of course, if I want a decimal, I could do that. 144 pi minus 288. So that's 164.39. Alright, so that would be the decimalized version of the shaded area right here. This is was in meters. We're doing area now, so meters squared. Okay, that's number 8. Alright, looking at number 9. Ah, muy fácil. If I do this one, volume, you just have to know the formula. The volume of a sphere is 4/3 pi times the radius cubed. So this is simply going to become 4/3 pi times 6.5 cubed. We're just plugging in the radius, and all this can go in the calculator. 4/3 pi times 6.5. Alright, that's our radius. Cubed. To do the third power on the TI-30XS multi-view, hit the caret, that bumps you up to the exponent, and we just type 3 for the third power. So that is 1150.35. volume. Okay, this is volume, so we will do centimeters cubed. That's how you do number 9. Okay. Now surface area. We will be slightly careful, but this is also muy fácil. The formula for surface area is surface area of a sphere is 4 pi r squared. So it's sort of like the area of a circle, but it's times 4. So all we need is the radius. Be careful, do not plug in 12 because 12 is not the radius. 12 here is the diameter, so that means 6 is the radius, like from here to here. So just put in 6 and you're going to get your answer. So surface area is 4 pi times 6 squared. Okay, so that means surface area. Let's see if we can get an exact answer this time. 4 pi 6 squared. I'm going to try typing all this in. 4 pi 6 squared. 144 pi. Okay, that is the exact answer for surface area. I can make a decimal by hitting toggle. 452.39 is the answer. Okay, this is surface area, so our units will be inches squared. Alright, let's look at number 11. Alright, for number 11, the circumference is this. Find the surface area. Look, if they give you circumference, then use the circumference formula, okay? The circumference formula is circumference equals 2 pi times radius. So they're giving us that the circumference is 96 pi. Please don't forget the pi. A lot of kids do that. So if I take this and I put it in for circumference, okay, then this is going to become 96 pi equals 2 pi r. So I'm going to get this radius, and then I'll use that to find whatever I want, like surface area. To get this radius, I will need to divide both sides by 2 pi, like so. The 2's cancel, the pi's cancel. Even these pi's will cancel. And of course, 96 divided by 2 is 48. We knew this. Okay, so far we know that the radius is 48. We just solved for it. But we are supposed to find the surface area. So we can now go on and find the surface area. I'll switch colors to show that we're moving into a different phase of the operation. Okay, back to purple. Surface area, as we saw in the previous problem, is 4 pi r squared. Alright, the surface area of a sphere. But now we know the radius. So I'm just going to take this 48 and substitute it for r right there. So this is going to become surface area equals 4 pi times 48 squared. Okay, let's see what the calculator does with that. 4 pi times 48 squared. 9,216 pi. Alright, so that is the exact answer right there. I could hit toggle and get a decimal. 28,952. 28,952.92. Okay, that would be the decimal answer. This is surface area, so I will use centimeters squared because it's area. Okay, let's do number 12. The surface area is this. So look, if they give me surface area, then we will use the surface area formula. So surface area equals 4 pi r squared. So if they're going to give us the surface area, we should take it and we should put it in where it goes, right where it says surface area. So this is going to become 384. There's no pi. The last time there was a pi, this time there's not, so just be careful. You know, write down what it actually says. Don't assume there will be a pi, because sometimes there's not. So anyway, let's keep going and find r. Once I have the radius, I can use that to find whatever I want, like the volume, for example. So to get this radius, first I need to divide both sides by 4 pi. Okay, so those are going to cancel each other out. The pi will not cancel out because there's only one of them. I bet this will reduce though. 384 over 4 pi. Let's see, 384 over 4 pi. Okay, they did not reduce that for me. So, you know, I'm just going to leave it like that. I don't care. 384 over 4 pi. So far, I've got that the radius squared is equal to, this is bugging me. Alright, the radius squared is equal to 384 over 4 pi. Now, if I want the radius not squared, then I need to take the square root of both sides, like this. Okay, so that's going to tell me that the radius is all this. Okay, I'm going to go ahead and get this decimal now to save you from what I really want to do. So, okay, square root of 384 over 4 pi. Okay, so square root of 384 over 4 pi. That gives me 5.5279, whatever. For right now, I'm going to write down 5.53. So that's my radius, 5.53. Okay, but I'm not finished because I have to keep going until I find the volume. So I'm going to take this radius and I'm going to substitute it into the volume formula. So you know that the volume formula is, I feel like I should switch colors again. Let me do green this time. The volume formula is 4/3 pi times the radius cubed. So I could put in this 5.53. So I need to take this radius, I need to cube it, I need to multiply by pi and 4/3. Now if I wanted a perfect answer, I would not round this number, and here's how I could do it. I need to cube this and multiply by pi and multiply by 4/3. I'm afraid I'm going to confuse you. Alright, you know what, I'm just gonna go ahead and round now. I don't want to confuse you. So we could just type all this into the calculator. So 4/3 pi times the radius cubed. So it'll look like this. 4/3 pi, there comes the radius, 5.53, cubed. So we got to do our little carry 3. So 4/3 pi radius cubed. So that gives us our answer. So 708.38. Okay, I would accept this as a teacher. Now, say if you, because I rounded this answer is a little off. say if you wanted your answer to be as accurate as possible. Let me see if I can show you how you would do that. This is a special trick, so you know, if this is going to confuse you, just fast forward to the next problem. But if you want to know the ultimate powers of your TI-30 XS Multiview, stay with me. So let me go back. So remember how I was typing this in? Okay. Yeah, so I was going to do 4/3, okay, and pi. Now, it's time to have the radius cubed, right? So I really wanted my radius right here. Here's how I could get it. If I go back up to where it is, and I hit enter right now, it jumps to where the last place I was. So now it is pasted in here, ready to go. So I can go ahead and keep it. Alright, so this is a more accurate answer. 707.57. This is better than what I had. Okay? 707.57. Alright, on a test though, I would accept either, but this one is more accurate. Alright, anyway, number 13. The volume of a sphere is this. Find the circumference. Okay, watch this very carefully. A lot of kids have trouble with this. If I give you the volume, do the volume formula, please. So we just saw that the volume is 4/3 pi times the radius cubed. So we will take this and substitute it in for v. So this will become, you know, I need to zoom in a little bit. Okay, so this is going to become 432 pi, don't forget the pi, equals 4/3 pi times the radius cubed. Now eventually we're going to find the circumference, but for right now we're just going to find the radius, and then we'll use that to get the circumference later. If I want to get the r by itself, I'm going to need to divide. You can just divide both sides by 4/3 pi, like this. Alright, that way all of this will cancel out and just leave r to the 3rd power. Meanwhile over here the pi's even cancel out. So I just have 432 over 4/3. Okay, it says 432 over 4/3. Okay, you can just put it all in the calculator. It's very powerful. That turns out to be 324. Okay, so far that means I have r to the 3rd power is equal to 324. Now if I want just plain old r, I'm going to have to get rid of this cube. How do I do that? Well, I use the cube root, of course. This line is bothering me. Just move it over. I could take the cube root of both sides, and it looks like this on paper. Cube root and the 3rd power cancel each other out, and so I will just have r. So how do I do the cube root on the calculator? 24. So on the TI-30 XS Multiview, if you want to do the cube root, you have to type the number 3 first. If you look above the caret button here, see how it says x and then a root? That means any root, whatever root you start with. So if I hit 2nd caret right now, this will become cube root, and I need it 324. That turns out to be this. So this is my radius. Okay, 6.87. Okay, so that's my radius. Now I could go ahead and find the circumference. Now, circumference is 2 pi r. So that means the circumference is going to be 2 pi times 6.87. Okay, again, if I want my answer to be as accurate as possible, I'm not going to round this. So watch the power of the calculator. I want 2 pi, and then I want this number, right? Because this is my radius. If I go up and I hit enter, it jumps down here. So 43.15. So the circumference is 43.15. That is the best answer, and this is going to be inches. And that is how you do that. Okay, last problem. Imagine that a balloon is inflated. Maybe I better zoom out again. Should I? No. Imagine that a balloon is inflated so that the diameter is tripled. Okay? Alright, how does the surface area change? How does the volume change? Excuse me, goodness. It doesn't matter that this is a balloon. They could have said airplane, television set, swimming pool. It does not matter. The changing length, area, and volume works the same for any kind of shape. So what I would recommend is going with a simple shape. For length, I'm going to use just a segment. Alright, this segment will represent length for me. For area, area can be represented by a square. Okay, so this would represent a square for me. I really got to make sure it's the same. Okay, see how, notice that the edge of this square is about the same, it's the same width as the segment. Okay, so I've got a square, I've got a length. Alright, so that's length, area. And now I need a volume. For volume, the simplest thing to use is a cube. Alright, I really want this to be the same size. Okay, so I've got length, area, and volume. Now, if we imagine that the original length was 1, then that would make this a 1 by 1 square, and the area would be 1. That would make this cube, if these lengths are 1, that means this is a 1 by 1 by 1 cube. 1 times 1 times 1 is 1. Okay, so what you find out is, you can imagine, you know, we're basically solving a simpler problem and knowing that the answer will be the same. So in my simple problem that I made up, I'm picturing a length, an area, and a volume that are all 1. Now, let's watch what happens if I change one of these, and let's see how the other ones change. Now, this says the balloon is inflated so that the diameter is tripled. Don't worry about the fact that it says diameter. Diameter is a length. Okay, so the key is that the length is tripled. That's what matters. So if the length is tripled, that means it used to be a 1, and guess what? It's tripled, so now it's a 3. But if that's a 3, then this is not going to be a 1 anymore. This is also going to be a 3 because all the lengths are tripled. But if these lengths are tripled, now the area won't be 1 anymore. This is 3 times 3. My new area is 9. Okay, so I have my new length, my new area. My new volume Alright, because the lengths were tripled, this is now 3 by 3 by 3. Okay, so my new volume, 3 times 3 times 3, is 27. Okay, so how does the surface area change? It doesn't matter that it says surface area. Okay, the key is that it's an area. All areas behave the same in this regard. So how does the area change? Well, the area went from 1 to 9. So we could say that it was multiplied by 9. Alright, in a similar way, how does the volume change? Well, remember, the volume was 1. Now it's 27. So we could say that the volume was multiplied by 27. Okay, if you had any trouble with that, we have whole videos on just this topic. This is the day 9 video. If you go back to day 5 or day 6, there are whole videos just on this. So if this confused you at all, go back and find the video that's all about changing length, area, and volume, and watch the whole 40-minute video or however long it is. Anyway, that's it for me tonight. It's time for me to go to bed anyway. It's like almost midnight, and here I am making videos for you guys. Hope you appreciate it. Love ya. I will catch you on the next video.